Okay, so when we have a radical in the bottom of a fraction, it is not considered simplified. So for example, 1 over root 7 is, if that was an answer, great, but that's not an appropriate answer because we can't have a radical in the denominator. Now how we rationalize these is not in a way, a lot of you just have it memorized, I multiply by root 7 because that's what I see on bottom. That's not how we have to think about it or else you're going to get confused when we get to harder stuff. So think about this, guys. What cancels out a square root? Something squared, correct? Isn't that when root cancels out with power? Something squared. So what we need under here is the square root of 7 times 7. So we need underneath our radical square root of 7 squared. How many 7s is under the radical? 1. Don't we need 2? Everyone? So you need one more 7. So you multiply by root 7 to the bottom and the top. You have to do it to the bottom and the top because then look, we're just multiplying by a fancy 1. Timesing by 1 doesn't change the problem. So now multiply straight across. 1 times root 7 is root 7 on top. Then on bottom, don't we have now the square root of 7 squared? The square root of 7 times 7 is 7 squared. So now look, on the bottom, root cancels out with power, leaving me with 7. So on top I have root 7, and on bottom I have a 7. Now some of you are thinking, well yeah, you just multiply by root 7 over root 7, just like I had it memorized. Yeah, but that's for these easy ones. Okay, yeah, it came out easy for these easy ones. But if you think through it like the way I just said, it's going to make our harder ones a lot easier. Okay, now first of all, look at this one, root 5 over root 12. The first thing we would check is, does 5 and 12 simplify if we were to put it together? 5 over 12 doesn't simplify, correct? So you'd split it apart and say, okay, I got to simplify the top and the bottom individually. So let's do that. Root 5 does not simplify, so we still have root 5, but 12 breaks down into 4 times 3, 2 times 2, doesn't it? So we can pull out a 2. So on bottom I have 2 root 3. Now you'd say that's my answer, but it's not an appropriate answer because I still have a radical on bottom. So what's going to undo the square root of 3? The square root of 3 squared, correct? So we need another 3 here. So we'd multiply by root 3 and root 3. So then on top I'd have root 15. And on bottom I have a 2. And then I have times the square root of 3 squared. So now doesn't root cancel out with power? Right here? So now it's just 2 times 3. So on top we have root 15, and on bottom we have 2 times 3, which is 6. You didn't rationalize it before you multiplied it. What do you mean? Yeah, you get the same answer. Yeah. Yes. Okay, so everyone look at this one. Rationalize the denominator. So, guys, we need the square root, we need a 2 squared, and we need an x squared, don't we? Times sign? Because then won't root cancel out with our powers, giving us just 2x? Okay, how many 2's do we have? 1. We need 2, so we need to multiply by another 2. We need it to be x squared. We already have 1, so how many more do I need? 1. Does everybody see the thought process here? So you multiply the top and bottom by the same thing, root 2x. So now on top I have 2 root 2x's, and on bottom I have 3 times the square root of 2 squared x squared. There's 2 2's and 2 x's. So now root cancels out with power, keeping in mind these are all multiplication signs. So on top I have a 2, a square root of 2x, and on bottom I have a 3 times 2 times x. Isn't that 6x? Do we have any questions on what I just did? Then your last step is to say, does anything more simplify? Don't 2 and 6 simplify? We can divide across multiplication signs, so this becomes 1 over 3. So my final answer would be root 2x over 3x. We would never divide something that's under a radical with something that's not, so we're done here. Okay, first of all, looking at this, guys, you really should be checking. Your life is going to be much easier if you first see if your radicals can simplify in any way. So 8 breaks down into 4 times 2, and then 4 breaks down into 2 times 2. So pull out a 2. So we have root 5 over 2 root 2's, correct? So then from there you'll say, okay, I need to rationalize my denominator because it is not appropriate to have a radical in the denominator. So I'm going to multiply by root 2, aren't I? Root 2, so then on top I have square root of 10, and on bottom I have 2 times the square root of 4 2 squared. So root cancels out with power. So we have root 10 over 4. Okay. Okay, now let's take that understanding and now do cube roots. So I always have people that don't understand how to rationalize denominators and they don't think through it the way I just saw it. They say, so I need to multiply by the cube root of 6. No, that's not going to fix anything. So everyone, we have to think through this correctly. What cancels out something the cube root? What cancels out a cube root? Something cubed, right, everyone? Root would cancel out with power. Now, really what we should be looking at is 6 is 3 times 2. 6 is 3 times 2. So look, if we had a 3 cubed and a 2 cubed, root would cancel out with power and give us just 3 times 2. So everyone, what you would do is I would factor this out. So I have 1 over the cube root of 3 times 2. There's a reason I do it this way, guys. It's not to make your life harder, but it really is to make it easier when we get to more advanced ones. So how many more 3's do I need to make it cubed? 2 more, because there's already 1. So I need to multiply by 2 more 3's. Does everybody see how that would now give us 3? 3's in the bottom. How many 2's do we have? 1. So I need to multiply by 2 more, because I need there to be 2 cubed on bottom. Whatever you do to the bottom, you've got to do it to the top. So we have the cube root of 3 times 3 times 2 times 2. So now on top, I have 1 times that, which is the cube root of 9 times 4, so the cube root of 36, which we already know does not simplify, because look, here it was broken down and there's no groups of 3. Now on bottom, don't I have this, the cube root of 1, 2, 3 3's, so 3 cubed, 1, 2, 3 2's, and 2 cubed, right? So now it's like, well, root cancels out with our powers, leaving me with just a 6 on bottom. So we have the cube root of 36 all over 3 times 2, which is 6. Do we have questions? Please ask. If so, yes. Yep, we would have. Yeah, great question. Yeah, so there's a reason I'm doing it like this, because what if 6 would have been 12? Then that would have been, you'll see why I do it this way in the next one, because it helps us not have to simplify it in the end. This one would have worked out the same either way. So let me show you one that would have been a little different. This next example here. So right now we have this, the cube root of 5 over 18. So that doesn't simplify, so we split out the top from the bottom. The cube root of 5 over the cube root of 18. So let me explain why I do it the way I just taught you. If you went through and did it this way, you could still get the correct answer. It's just going to be harder to get there. So how many 18's do I need? 3, right? To make it cubed, everyone? So how many more 18's would I need? 2 more. That would work. However, that's making your life way harder. You're going to have to simplify a lot more, because 18 and 18 have a lot of stuff we could break down. So if we do it this other way, we won't have to simplify in the end. So let's not do it that way. Instead, let's break the 18 into its factors. Because then we're going to multiply by the lowest amount to rationalize the denominator. So let's rewrite this. What we're really looking at is this. The cube root of 5 divided by the cube root, doesn't 18 break down into 9 times 2? And then 3 times 3? So really what we're looking at, this problem is the exact same as looking at 3 times 3 times 2. Now the reason I do that is because now I'm going to actually rationalize with a smaller amount than 2 18's. I only have to have, how many more 3's do I need in this one? Only 1 more, because there's already 2 and we need it cubed. So I only have to multiply by 1 more 3. Now right here, how many more 2's do I need? 2 more. So now we'd multiply the top by the same thing, the cube root of 3 times 2 times 2. Now look how nice that is. But the reason we do it like this is because now look, on top we have this, the cube root of 5 times 3 times 2 times 2. We can already see that nothing breaks down and pulls out groups of 3. So we know that won't simplify. So we'll have 5 times 3, which is 15. 15 times 4, right everyone? 60. And we already know it doesn't simplify. We don't even have to check, because we already saw right here it didn't. Then on bottom, don't we have the cube root of 3 cubed, 2 cubed? So then root cancels out with power, leaving me with a 6 on bottom. So we have the cube root of 60 all over 6. So the reason we do it this way is just to make our life easier in the end so we don't have to simplify. Because if we would have done the 18s, we would have had to actually simplify the top, which would come out with the same answer, it's just a lot more steps. So, yeah, great question. Didn't we just see that the factors of 60 were 5, 3, 2, and 2? So we already know there's not groups of 3. That's what makes this way nice. Yes. Yeah. Yeah, because cube roots cancel out with cubes. Square roots cancel out with squares, right? Fourth roots cancel out with degree 4. Do you see the pattern? Okay. Okay, let's do another one like that. Okay, so now let's see a fourth root here. Once again, if you do it the way I'm teaching you here, your life is going to be so much easier. So you'd say, okay, I have 6 over the fourth root of 4. I'm going to break this down so that I can see exactly how many more of things I need to multiply by. Meaning, break it down into its factors. So we have 6 over the fourth root of, isn't 4 2 times 2? And then we have 1, 2, 3 z's. Okay, that's what we're looking at right now. Now to cancel out a fourth root, we need something to the 4th power. Look, we need it to the 4th power. So we're going to multiply by the 4th root of, how many more 2's do we need? 2 more, because there's already 2 of them. I don't know why I did 4 to the 4, that wasn't smart. So it would have been 2 before. Okay, and then how many more z's do we need? 1 more. So we have the 4th root of 2 times 2 times z. Now the nice thing is, because we did it this way, we don't have to simplify under a radical up here. So we have 6 fourth roots of 4z, which we already know doesn't simplify. Then on bottom we have the 4th root of 2 to the 4th, z to the 4th. So then root cancels out with power. So now we have this, 6 fourth roots of 4z all over 2z. But now you would check, is anything more simplified, is anything more divide out? Doesn't 6 and 2 divide out? To become a 3 up here. So 3 fourth roots of 4z's all over z. So really my first step is to, if the radical doesn't simplify and pull anything out, what I'm going to do is break it down into its factors and then multiply by the least amount possible to rationalize it. Okay, I think we probably get the picture here. Let's make sure we're good. So on top we have the cube root of 3. It didn't simplify. 3 and 20 didn't simplify. We would check that first. Now we have the cube root of 20. Now you'd say, okay, what are we actually looking at? We're looking at the cube root of 3 divided by the cube root of 5 times 4, right? So that's 5 times 2 times 2. We want it down to its like factored completely form. So then we'd say we need how many more 5s? 2 more. And then we only need 1 more 2. So now the top, we already know 3, 5, 5, and 2. No groups of 3, so we just put it together. So 25 times 2, right? 25 times 2, so that's 50, and then 50 times 3. And then we already know it doesn't simplify, because there's the factors. And then on bottom, we would have 5 times 2. Can everyone just see how it's 5 times 2 without me actually writing out why it's 5 times 2? Because it's 5 cubed, 2 cubed, the cubes cancel out, that's 5 times 2, which is 10. Okay, awesome. I think we get that. So we won't do any more if you're good. I think you're good. Okay, so here's the thing, guys. We're almost done with this lesson. When rationalizing the denominator with 2 terms, it does take more thought process. So everybody look right here. I have 2 terms. This isn't a denominator. I'm just showing you something. This is a leading up to rationalizing the denominator with 2 terms. Watch what happens when I multiply these out. I want to point something out. Aren't these conjugates? Conjugates means same term, just a change of sign in the middle, in between only. A change of sign in between. So what happens when we multiply out conjugates? The middle term cancels out. Let's see what happens when we multiply out conjugates with rationals involved. 1 times 1 is 1. 1 times negative root 2 is negative root 2. Positive 2 times 1 is positive root 2 times 1 is positive root 2. Right here, don't mess this up. Positive root 2 times negative root 2 is negative root 4. Now look, our middle terms cancel out because that's what conjugates do. So then don't we have 1 minus, what's square root of 4? So we're actually dealing with 1 minus 2, which is negative 1. In our answer, is there any more radicals? No. So notice conjugates with radicals involved will cancel out the radical part. Well, that's going to be useful because look, if we look at this problem here, you say, okay, nothing more can simplify. The radical can't simplify, nothing can divide out. We can't divide across addition signs anyways. So you'd say, that's my answer. It is not an appropriate answer because we have this root 3. Now watch, I always have people say, okay, so I'm just going to multiply by root 3. Well, if you do that, then look what happens. You have 4 root 3 on top, and then on bottom, since you said multiply by root 3, you'd have to distribute, and you would get root 9 plus root 3, which is 3 plus root 3. Did you fix anything? No. So that's the problem. If you have two terms, the old-fashioned rationalizing won't work because you'll distribute the radical through and it won't help us. So instead, you're just going to have to know if we have a radical with two terms on bottom, to fix it, we need to multiply by the conjugate. So the conjugate would be root 3 and then what? Minus 1. So if you do that to the bottom, you got to do it to the top. Root 3 minus 1. So now you have 4 times all that stuff. We got to distribute. So that would be on top. 4 root 3 minus 4. Then on bottom, we've got to distribute that out, knowing that the radicals should all cancel out if we do it right. Root 3 times root 3 is root 9. Root 3 times negative 1 is negative root 3. Positive root 3. Middle terms should cancel out. And then we have minus 1. So my root 3's are gone. I have root 9, which is 3. 3 minus 1 is 2. So in our denominator, I have a 2. So that took care of the radical. So now what you would do is say, okay, remember, we know we can't divide across subtraction signs, but as long as we divide all three things by something in common, we can divide out something. So what do they all divide by? 2. This divides by 2 and becomes a 1. This divides by 2 and becomes a 2. This divides by 2 and becomes a 2. So our final answer would have been 2 root 3 minus 2. Divided by 1 is not necessary to write. Okay, looking at this one, what would I multiply by? Yep. The square root of 6 plus the square root of 2. Let's do one more, and then if you guys are good, we'll call it good. Root 6 plus root 2. So now I've got to distribute. Root 2 times root 6 on top is root 12. Root 2 times root 2 is plus root 4 though, right? Plus root 4. Now we got to simplify those radicals on top because in this one the radicals simplify. This breaks down into 4 times 3, so then we can pull out a 2. So this became 2 root 3 on top plus 2. Now on bottom, we would go off to the side. I'll remember, I'm going to do my work over here off on the side. Root 6 times root 6 is root 36. Then we have plus root 12. Then we have a minus root 12. Our middle term should always cancel out. And then we have minus root 4. Middle terms canceling out. Great. Root 36 is 6. So we have a 6. Then we have a minus sign. Then we have a 2, which is 4. So our bottom became a 4. Do all three things divide by something in common? A 2. This divides by 2 and becomes a 1. This divides by 2 and becomes a 1. This divides by 2 and becomes a 2. So our final answer is 1 root 3 plus 1 all over 2. And now look, the radical's not in the denominator anymore. Fun fact for you though, this answer is equivalent to this answer. This is just the appropriate answer just because it's not considered simplified to have a radical in the denominator. Would it be appropriate, guys, to divide out these root 2's? Sure. No, because I'd be dividing across a subtraction sign. Can't do it. Okay, I think we have a picture, so I think we're good. Don't you agree? Okay, awesome. Okay, so do 7.5 odds or evens go. I would go practice these ones right now. These ones are probably a little bit harder than the last ones.